So still under linear circuits involving dependent sources, we are going to use superposition theorem to find the value of Vx in this question. Now this happens to be our first example. Let's try to solve this example together. Now looking at this circuit, you realize that we have two independent sources. We have 20 volts and then 4 amperes current source. And then we have a dependent source which is 0.1 Vx current source. Now with superposition theorem, what we do is we consider one of the independent sources at a time and then we deactivate the other. Later we consider the other one and then we deactivate the initial one. So you use superposition theorem whenever you have more than one independent source. So in the first step, we are going to consider the 20 volts and then deactivate the 4 amperes current source, and then we try to find the value of Vx. So first, let 20 volts act alone. So because this is a current source, it's going to be an open circuit. So when 20 volts is acting alone, like we said, we are going to deactivate the 4 amperes current source. Now the next thing we are going to do is to do current distribution. So we have current I produced by the 20 volts. This current flows through this direction, and then at this point we have current I1 flowing in this branch. Now considering this loop, we have the source voltage to be 20 volts, and that is equal to the sum of the voltages dropped across the loop. So we have 20 times I, because we have I flowing through this resistor, and then plus we have 4 times I1. Now let's call this equation 1. Now you should realize that we have this current source 0.1 Vx moving in the anticlockwise direction, and then it's going to combine with I at this node, and then they both flow through this branch. Therefore we have I1 to be equal to I plus 0.1 Vx. So this is the value of, or this is the expression for I1. Again, so the current I produced by the 20 volts flows through this 20 ohms resistor, and then as it flows through the resistor, some of the voltage is being dropped across the resistor. Now the left voltage, the voltage that is left, is said to be the voltage Vx, and that is the voltage across this 4 ohms resistor. Therefore we have Vx to be equal to the voltage across this resistor, which is I1 times the value of the resistor. So we have Vx to be equal to 4I1. Let's call this equation 2. Now we are going to put equation 2. We are going to put equation 2 into I1. So for I1, we have I1 equals I plus 0.1 times Vx, which is 4I1, and that becomes I plus 0.1 times 4 is 0.4, and then I1. Now we are going to transpose 0.4 I1 to the left hand side, so that's going to be I1 minus 0.4 I1, which is 0.6 I1 equals I. So let's call this equation 3. Now we are going to put equation 3. We are going to put equation 3 into equation 1. So that is 20 equals 20 times 20 equals 20 times, in place of I we have 0.6 I1, so 0.6 I1 plus 4 I1. Now 20 times 0.6 becomes 12, so we have 12 I1 plus 4 I1 equals 20. Now this becomes 16 I1. So we divide through by 16, and then you have I1 to be equal to, now 20 over 16 gives 1.25. So we have I1 to be 1.25 amperes. Now if that is the case, then we can find the value of Vx. We can find the value of Vx, which is equal to 4 times I1. So that is 4 times I1, 1.25, and that is equal to 5 volts. Now, since Vx is as a result of 20 volts acting alone, we are going to call this Vx prime. So that is 5 volts. Again, we are going to deactivate 20 volts and then make 4 amperes act alone. So for 4 amperes acting alone, we say let 4 amperes act alone. So let's redraw the circuit. So we are going to have 20 volts becoming short circuit. We have this 20 ohms here. This is Vx, and then we have the current source 4 amperes. We have this resistor 4 ohms, and then we have the current source, dependent current source. So let's try to find the value of Vx. Now, whenever you go through a loop without passing through any other circuit element except 2 resistors, then it means that those 2 resistors are connected in parallel. So 20 ohms and then 4 ohms are connected in parallel. So we can have the parallel combination. That is 20 parallel 4, that is 20 times 4 over 20 plus 4. Now this becomes 80 over 24. 8 goes here 3 times, 8 goes here 10 times, so that is 10 over 3 ohms. So we can redraw the circuit such that we have this to be 10 over 3 ohms. We have the current source, which is 4 amperes, and then we have the dependent current source. So this is the independent, this is dependent, that is 0.1 Vx, and then we have this to be Vx. Now we have 4 amperes, 0.1 Vx combining at this node and then moving in this direction. So that is 4 plus 0.1 Vx. Now the voltage across this resistor is Vx. The voltage across this resistor is Vx. So we have Vx to be equal to the current 4 plus 0.1 Vx times the value of the resistor, which is 10 over 3. So at this point we can cross multiply. So that's going to be 3 Vx equals, here we have 4 plus 0.1 Vx times 10. So we multiply 10 across, we have 3 Vx equals 40 plus Vx. We transpose Vx to the left hand side. We have 2 Vx, that is equal to 40. We divide through by 2 by 2, and then we have Vx to be 20 volts. Now because this is as a result of 4 amperes acting alone, let's call that Vx prime prime. Therefore, the value for Vx is given as Vx prime plus Vx prime prime, and notice that we had Vx prime to be 5 volts, so 5 plus Vx prime prime 20, and that is equal to 25 volts. So the value of Vx is equal to 25 volts. Now let's move on to the next example. So in our next example, we are going to use superposition theorem to find V0 in the circuit below. So as usual, we have more than one independent sources. So we are going to consider one and then deactivate the other, and then later we consider the latter one and then deactivate the initial one. So first, let 10 volts act alone. So we deactivate 2 amperes. So at this point, we've been able to redraw the circuit, deactivating the 2 amperes current source. Now we are supposed to assign current and then find the value of V0. Now sometimes it's very difficult to easily identify whether this 2 ohms resistor is in series with this 1 ohm resistor, or better still, the two are in parallel. Now what we are going to do here is to borrow the principle of source transformation. Now what does this principle say? It says that assuming you have a voltage source, let's say you have a 10 volt source which is in series with, let's say, a 2 ohms resistor, okay, then you can transform this circuit such that you have a current source which is this time in parallel with the resistor. So a voltage source in series with a resistor can be transformed into a current source in parallel with that same resistor, and vice versa. So if you want to find the value of the current source, basically we are going to use Ohm's law. So from Ohm's law, we have V is equal to I times R. Now if you want to find the value of I, then it's nothing but V divided by R. You have V to be 10, you have R to be 2, so this is equal to 5 amperes. So you have this to be 5 amperes in parallel with 2 ohms. So this is how the principle of source transformation works. So we are going to deploy that here. So instead of having 1 ohm in parallel with 0.5 V0, we are going to find the value of the voltage. Notice that this is a current source, so to find the voltage is basically the value of the current source 0.5 V0 times 1, which is still 0.5 V0. Notice that this time the unit is in volts. So we are going to have 0.5 V0, which is in volts, in series with this 1 ohm resistor. So let's redraw that circuit. So that's going to be now again, notice that the polarity of the voltage source should be in line with the direction of the current. So you realize that we have the positive pointing upwards, so the direction should be upwards. The same way applies to this. We have the direction of the current source moving to the right. We have the positive also at the right. Now we assign currents, let's say I, and then we want to find the value of current produced by the 10 volts. Later we can find the value of V0. So let's try to find the value of I. So we have I moving throughout the circuit, and then we are taking the clockwise direction. we have the source voltage to be 10 plus 0.5 V naught. Notice that we have the polarity in the same direction, so it's going to be 10 plus 0.5 V naught. That is equal to, we have 2I plus I plus 4I. Now this combines to 7I. So we have 10 plus 0.5 V naught equals 7I. Now again, the voltage V naught across the 4 ohms resistor is equal to the value of the current flowing in the branch times the value of the resistor. So we have V naught to be equal to current flowing in this branch is I, so that is 4 times I. This is the value of V naught, or the expression for V naught. We are going to put that in this equation, and then you realize that we have 10 plus 0.5. in place of V naught we have 4I equals 7I. So this becomes 10 plus 0.5 times 4 is 2, so 2I equals 7I. We transpose this to the right hand side. We have 10 equals 7I minus 2I, which is equal to 5I. So we divide through by 5 by 5. We have I to be equal to 2 amperes. So this is the value of I. Now to find the value of V naught, that is equal to 4 times I, and then we have 4 times 2, which is equal to 8. Therefore V naught is equal to 8 volts. Now because V naught is the value of the voltage across 4 ohms resistor as a result of 10 volts acting alone, we call this V naught prime. V naught prime. So next we are going to consider 2 amperes acting alone. So considering the original circuit, we are going to let 2 amperes act alone. 2 amperes acting alone. This becomes a short circuit. We have this to be the current source 2 amperes. And then again, deploying the principle of source transformation, we are going to have the resistor in series with the dependent voltage source. So that's going to be 0.5 V naught from the previous section. And then we have the resistor 4 ohms V naught. Now let's try to find the current flowing through V naught. So again, we have an issue here. It's very difficult to determine how the current will be distributed in this circuit. Again, we are going to use, or we are going to deploy the principle of source transformation the second time. So this is what we are going to do. We are going to transform this current source, which is in parallel with this 2 ohms resistor, to be a voltage source in series with this 2 ohms resistor. Now if you want to think of this as in parallel, you can, let's say, clean this and then come and put that here, and so you realize that it is in parallel. Okay, so we are going to transform this so that we have a voltage source. So using Ohm's law, from Ohm's law we have V equals 2 times 2, which is equal to 4. 2 amperes times 2 ohms, that is 4. So we have 4 volts in series with 2 ohms, and then you have this 1 ohm, and then dependent voltage source 0.5 V naught, (4 ohms). So we assign current I, and then we take the clockwise direction. We have the sum of the source voltages to be 4 plus 0.5 V0, that is equal to, going around the loop, we have 2 plus 1 plus 4, which is 7. So 7i, and then we have V0 to be equal to I times 4. So 4i, we're going to put this back into this equation. So we are going to have 4 plus 0.5 V0, and then we have V0 to be 4i. So 4i equals 7i. So this becomes 4 plus 2i equals 7i, and then we have 4 equals 7i minus 2i, that is equal to 5i. We divide through by 5. By 5, we have I to be equal to 0.8 amperes. Now, since we are interested in the value of V0, we have V0 to be equal to 4i. So 4 times 0.8, which is equal to 3.2 volts. So since this value of V0 is as a result of 2 amperes acting alone, we call that V0 prime prime. Therefore, the original value of V0 is equal to V0 prime plus, we have V0 prime plus V0 prime prime. Now in the previous section, we had V0 prime to be 8 volts. So we have 8 plus V0 prime prime 3.2, and that is equal to 11.2 volts. So this is the value of V0. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.